all this math concept, but we use in economics. Why? To define some complicated concept in easy way, or at least in short way. So the example of using set in economics is like consumer theory. In the consumer theory, you have a concept, and that concept that says like consumption set. Consumption set. You see, this consumption is an economics concept, but the set here is a math concept. Why we need to use set in order to explain our consumption? Because when we are consuming for our daily life, it's not only one or two goods or services. There are many things that we consume. From clothes, from eating, like for our studies, for our transportation. So there are many things that in our daily life we consume. So if we write the name of everything that we consume in daily life, maybe we need like thousands of pages, hundreds of pages to write all of them, just as a one consumer. If you use those materials that you need for your study in this semester, there are many things. There's pen, pencil, tablet, lecture material, different lecture material. All of them, if you use, it will take a lot of space and a lot of time. But in economics, we use the concept of sets in order to define our consumption, just with one symbol, X. And this X is a set of our consumption goods and services. And we explain those consumption bundles as a L. You see, just with having two symbols, X and L, X is a set, and L is the element inside that set. So we explain a very big consumption, communities and goods in just a set, a small set. For example, when we define like this, X is our consumption set, which is an RL plus. X is a consumption set in RL plus. What does RL plus mean? Do you know? RL plus. What do you think RL plus? You don't know? So when we have R, this R means real numbers. When we have one positive, it means non-negative. Why non-negative? Because we do not consume negative amount of something. If someone asks you, how many apples did you eat during the lunchtime? You may either say none, I didn't eat anything. You may either say, if you use that one, if you eat, you may say, okay, one or two. Can you say -3? I eat -3 apples. It doesn't make sense. Because when it comes to consumption, either we use some positive amount of something or zero amount of something. Non-negative means zero included. Only negative numbers or negative value do not include. What does L means? The number of goods that you have or the number of bundles of goods that you have in your consumption set. L is the number of goods, R is real number, is a set, and positive, it means non-negative. So when it comes to R, we have those three symbols, R plus, and R plus plus. What is the difference between these three symbols? And you may have a lot of time in microeconomics. R plus, and R plus plus. Infinite. Yeah. 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 So when we say R is just real number, you can use this one as a symbol of number. So real number means it starts from negative infinity up to positive infinity, including zero. Including zero. And when we say R plus, it's to start from zero to positive infinity. It starts from zero to positive infinity. So when you see in your microeconomics class something as a R plus, it means that R plus is a set of numbers, commodities, elements. When we think about set, whatever inside of that set, we can say elements. So it means the element of that set starts from zero up to positive infinity. You can consume zero amount of something up to whatever you want, and you can. But when we say it's R plus plus, it means it's strictly positive. It's strictly positive. What does strictly positive means? It means so we start from sets of positive real number, but zero itself is not included. So we start after zero. So it means there are some positive things. Like when you go to production theory, in the producer theory, you may say that R plus plus. Why R plus plus? Because in the producer, in the company, you cannot produce something out of nothing. Can you produce something out of nothing? What do I mean by this sentence? Something out of nothing. Yeah. It means like for producing a good, suppose for producing this marker, we need some raw material, and we need machine, and we need some workers to make it. So it means in that case, if there is nothing, for example, there's no raw material, there's no human labor, and there's no machine, so we cannot expect this marker. So in the case of producer theory, you may face a lot of time for this R plus plus. So when you see R plus plus, it means everything there is positive. It means there should be something to have another thing positive. Otherwise, if it's zero, so the result will be also, what will be the result if there is zero? It's also zero. So if it's zero, the result is also zero. So one of the things that we like use the set in economics is to like explain very complicated concept in easy way. So there are two very basic concepts of set that we use mostly in microeconomics: necessity and sufficiency. This one, necessity and sufficiency. What do you think? What necessity means? Just ignore this like complicated definition here. Can you give me an example of necessity in our daily life, in real life? Water. So how it can be necessity? how you can explain that one in a kind of academic way? Yeah. Mm-hmm.
That's what daily life.
Yeah.
I need vegetables.
Yeah.
So this is important.
Yeah.
But without it, I can still stay in life.
Yeah.
But if I mean like remove for example water,
Yeah.
I don't drink any water during some couple of days, I'm gonna
Yeah.
die. So I think water as necessary.
Mm-hmm.
Fruit and legumes still good, but not really necessary.
So yeah, he said a very good example. Any example in your like daily life? Oxygen. So how? Mm-hmm. Yeah. You see, when we define the concepts of necessity, it means something is necessary for doing something, but not completely sufficient. That means, okay, to live our life, we need oxygen, but it's not sufficient. Without oxygen, beside oxygen, we need food, we need water, and we need many other things. Yeah, the same as the example that you said. To live our life, water is necessary. Yeah, but it's not sufficient. Why? Because for having our life, we need also to breathe, and for breathing, we need oxygen. Yeah, even although just keep aside eating, if just compare water and oxygen, both of them separately necessary for our life, but they are not sufficient. Like another question, another example, if I say, to drive a car, it's necessary to have a license. I mean, you can drive illegally, but to drive a car legally, we need what? We need license. But do you think having a license is sufficient for driving a car? Yeah, we need the car. But if I say another example, having a automated car like Tesla, that there's no need for driver. So in this case, am I talking about necessity or sufficiency? There's no driver, there's no need for license, but it's just a car, and you can say there is no need for license, no need for driver. In this case, it's necessity or sufficiency. How? Because still we need to charge it. Can you go with a like automation car without charging it? Yeah. If someday we have an automated car that there is no need for driver, no need for fuel, no need for charge, then at that time you can say it's sufficient. Okay, let me give you an example of sufficiency. So, for example, this marker, the price of this marker is like 1,001. How much money do I need to be sufficient to buy this marker? This marker, the price of this marker is 1,001. How much money do I need to be sufficient to buy this marker? 1,000. But does it necessary? No, I can have more. I can have more. It's not necessary that I should have 1,001. I can have more, but still buy this marker. But listing that is not possible. So it means for sufficiency means that you can do something and either you have more things of that. It means you have that much money to buy this marker and you can still have more money. So it means it's not completely necessary that you should have 1,000, not more than that. And this two concept, necessity and sufficiency, is very useful in the concepts of microeconomics. So there are many other examples. For example, there's written contrapositive statements, there's written equivalence, there's written like some theorem and proof. And the thing is, why out of those concepts in microeconomics, we need those sufficiency and necessity and sufficiency more than other concepts. Because for explaining most of the things in microeconomics, we need to have both of them at the same time. We need to have both of them at the same time. And if we have both of them at the same time, we have a kind of symbol for that. IFF. So what does it mean? Maybe there is a lot of things in your lecture material that we have this. If and only if. Why?
A inside B.
Mm-hmm.
You know that A
Mm-hmm.
two.
Mm-hmm.
If only
Necessity means if. Yeah? For example, if I drink water, I can live my life. And only if, it means it's sufficiency. So I can buy this marker only if I have 1,001. If you have less than, you cannot buy. Only if. So then if we combine both of them, so we use as a symbol IFF. So it means as a big concept, if and only if. So it means at the same times you should have both concepts. At the same times you should have both concepts. You should have necessity and you should have sufficiency. You should have necessity and you should have sufficiency. For example, the Levy just said about representation theorem, like how to prove utility function. There you have this kind of things like ux is greater than and equal to ui if and only if x is at least as y. You see, in the representation theorem, when you prove utility function, when you prove that we can explain our preference relation by a utility function, and when we try to prove that utility function, so we have this kind of relationship. That ux, that utility that you get from x, is greater than and equal to the utility that you get from y. If and only if x is at least as y, at least as good as y. So when you have this kind of things, it means at least as good. At least as good. X is at least as good as y. So in that case, we have a nicely utility function that can explain our preference relation. Otherwise, there is no utility function. So that's why if and only if there's IIF, there's double F, IFF. So you have a lot of these concepts, IFF, in your microeconomics class. Later on, when you cover mostly game theory, like oligopoly market, and also you cover equilibrium, you have a lot of using of this IFF. So that's why now we need to know the concepts of sufficiency and necessity in order to explain this concept here. If we don't know what IFF really explains, so can we understand the rest of the things here? Okay, we know UX, we know UY, we know X, we know Y. We know this is greater than, so equal to and greater than, so this is at least as good as. So how about this one? So this one comes from this concept, necessity and sufficiency. So that's why we need to cover some mathematical concepts. And so this is what we have here: equivalence, example theory, and proof, and elements of set theory. Okay, so now, can you see? For example, when it comes to set theory, we can express our set in two ways. One is to include all the elements of your set inside of that set. For example, set S have the elements of 2, 3, 6, 8 inside. 2, 3, 6, 8 inside. And also, we can explain set by symbol. We can explain X by symbol. So let me give you an example. We can have like two types of explanation. X is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9, 10. Or another explanation, to make it simply, we use symbol. We use symbol. Or like we use this symbol, so let me write this one separately. This is S. Our set, this is S. And instead of writing this many numbers, we can simply write this set of S, or just simply we can write such that X is less than and equal to 10, greater than and equal to 1. So both of them exactly the same thing. The first one also shows the elements of the sets 1, 2, 3 up to 10. The second one also exactly shows the same thing, that S is a set of X, X is elements. And this elements of sets is less than and equal to 10, greater than and equal to 1. So all those numbers between 1 and 10, including 1 and 10, are the elements of the sets.